Hello friends, welcome back to the lecture series on the topic matrix analysis. In today's lecture, we will discuss Cayley-Hamilton theorem and we will see how we can find inverse of a matrix by Cayley-Hamilton theorem or by using characteristic equation. Now, Cayley-Hamilton theorem states that every square matrix satisfies its own characteristic equation. That is, if f of lambda is equal to 0 is a characteristic equation for the matrix A, then by Cayley-Hamilton theorem, this characteristic equation satisfied by matrix A. That means this f of A is equal to 0. This is the Cayley-Hamilton theorem for the given matrix A. Now let us discuss this theorem with some examples. Now example 1, verify Cayley-Hamilton theorem for matrix A is equal to 2 minus 1 1 minus 1 2 minus 1 1 minus 1 2 and find A inverse. Now solution. Now first we write characteristic equation for the given matrix A. Therefore characteristic equation is determinant A minus lambda times I is equal to 0. Now I am going to tell you some simple tricks for the expansion of determinant A minus lambda I. Now, order of A is 3. Therefore, we write the characteristic polynomial of degree 3 as lambda to the power 3 minus S1 lambda square plus S2 lambda minus determinant A is equal to 0. Now, where this S1 is equal to sum of the diagonal elements of the given matrix A. Sum of these diagonal elements is equal to 2 plus 2 plus 2 is equal to 6. And S2, this S2 be the sum of the minors of the diagonal elements, means M1 1 plus M2 2 plus M 3. These are the minors of the diagonal elements of the given matrix A. Now this is equal to this M11 means this is the minor of the post diagonal elements. Now it is the determinant obtained by deleting the post row and post column in the determinant A. Answer is deleting this post row column, we get determinant 2 minus 1 minus 1 2 plus M2 2. So this is the minor of the second diagonal elements. Again deleting the second row and second column in the determinant A, the answer is 2 1 1 2 plus M3 3. This is the minor of the third diagonal elements. Deleting the third row and third column in the determinant A, 2 minus 1 minus 1 2. This is equal to 4 minus 1. This is the expansion of this post determinant plus here 4 minus 1 plus again here 4 minus 1. So this answer is 3 plus 3 plus 3 means 9. Now determinant A. The determinant A is equal to determinant of the given matrix. Now expansion of this determinant starting with this 2. So this is equal to 2 times 4 minus 1. Here minus, this is the minus 1. Therefore this is plus 1 times 2 plus 1. This 1 plus 1. Answer is 1, 2. This is equal to 2 times this 4 minus 1, 3. So 2 times 3, answer is 6 minus 6 minus 1. Here answer is 4. So therefore, the characteristic equation is lambda to the power 3 minus S1. Here S1 is 6 times lambda square plus S2. S2 is 9 times lambda minus determinant A minus 4 is equal to 0. So this is the characteristic equation for the given matrix A. Now, to verify Cayley-Hamilton theorem, that is, to satisfy this characteristic equation by given matrix A, that means to prove that A to the power 3 minus 6 times A square plus 9 times A is minus 4. So here this is the minus 4 times I is equal to the 0, means here 0 matrix. For this, first we find A square. So therefore, A square is equal to A times A be the given matrix. Now this is equal to, now multiplication of these two matrices means this row, first row into first column. Answer is 2 times 2 means 4 minus 1 times minus 1 means plus 1 and plus 1 times 1 means again plus. Again first row into second column, so minus 2 minus 1. Now first row into third column, the answer is 2 plus 1 plus 2. Now second row into first column, second row into second column, second row into third column. So these calculations for you. Third row into first column, third row into second column, and third row into third column. So this such type of calculations for you. So this is equal to this 4 plus 1 plus 1 means 6 minus 5 and 5. Similarly, A to the power 3 is equal to A square times A. This is equal to A. Now multiplication of these two matrices is equal to this first row in first column. This is equal to 6 times 2, 12 plus minus 5 times minus 1 plus 5 plus 5 times 1. Again first row into second column, so minus 6 minus 10 minus 5. Similarly, first row into third column, 6 plus 5 plus 5 times 2, 10. Now second row into first column, second row into second column, second row into third column. Similarly, third row into first column, third row into second column, the third row into third column. So these simple calculations for you. This is equal to, now this 12 plus 5 means 22 minus 21. 6 plus 5, 11, 11 plus 10. Is the minus 20 to 20. 21 minus 21. Therefore, a to the power 3 minus 6 times a square plus 9 times a minus 4 times I. Now a to the power 3 matrix minus 6 times a square plus 9 times a 4 times I be the identity matrix of order 3 by 3, 1 0 0 0 1 0 0 0. Now this is equal to, now 22 minus 6 times 6 minus 36 plus this 9 times 2 18 minus 4 times 1 minus 4 minus 21 minus 21 6 times minus 5 plus 30. This is minus 9 minus 0. 21 minus 30 plus 9 equal calculations. Now this is equal to, now 22 minus 36 means minus 14, minus 14 plus 18 means plus 4. Now plus 4 minus 4 answer. So in minus 21 plus 30 plus 9 plus 9 minus 9. 21 minus 30 minus 9 minus 9 plus 9. Similarly, this is equal to 0 matrix. Therefore, a to the power 3 minus 6 times a square 9 times a minus 4 times I is equal to 0. Therefore, Cayley-Hamilton theorem is verified. Now, to find A inverse by using Cayley-Hamilton theorem, so multiplying this whole equation by A inverse. The A inverse times a to the power 3 answer is a square minus 6 times a inverse times a square answer is a plus 9 times a inverse times a answer is I minus 4 times a inverse times I answer is a inverse and a inverse times 0 answer is 0 matrix. Therefore, now this minus 4 a to a inverse, the answer is 4 times a inverse is equal to a square minus 6 times a plus 9 times I. This is equal to a square. The a square be the 6 times a be the given matrix. 2 plus 9 times I be the identity matrix 1 0 0 0 1 0 0 0 1. Now simplification, this is equal to 6 minus 6 times 2 12 plus 9 times 1 9. Again this minus 5 plus 6 plus 0 5 minus 6 plus 0. This is equal to this 6 minus 12 minus 6 plus 9 3. This is the 1 minus 1 1. Again here 3 1 minus 1 1. So this is the 4 times A inverse. Therefore, therefore A inverse is equal to 1 by 4 given matrix 1 3 1 minus 1 1 3 1 minus 1. So this is the required inverse the given matrix A by using Cayley-Hamilton theorem or by characteristic equation. I hope all of you have understood this topic. Please subscribe this channel. Stay happy, stay healthy. Have a nice day. Thank you.